Good afternoon. We're looking at Chapter 8, Section 2 still. We're covering hypothesis testing, the z-test for mu, the mean, population mean, of course. And we're going to basically here, in this example, compare and contrast the traditional method of hypothesis testing and the p-value method. So we're going to maybe take a peek at example 8-6, maybe take a peek at example 8-7, but basically, just go through the steps one by one. And hang on one second. Okay, so I just wanted to catch up here and write a little stuff out so that I can, keep pace talking and writing at the same time. I always have difficulty. All right, so here I've set up a little chart to just compare the methodologies, the step-by-step processes by which we do the traditional method versus the p-value method. Okay, so I've already written step one. Step one is you state the hypotheses. So you state the null hypothesis and the alternative hypothesis, or you write out what here is H subscript 0 and here is H subscript 1. This is what they are. And for the p-value method, we do the exact same thing. So this one is exactly the same. So then the next thing is, in the traditional method, let's start there. We're going to find the critical region. All right, so that usually involves sketching the distribution curve, identifying the type of test that it is, and drawing the corresponding region, approximately. And then you go in and you find those critical z values according to what alpha is. Whereas with the p-value method, we just go ahead and take all of the information from the problem, use the hypothesized value of mu that we had in H subscript 0, and we just go ahead and compute the z-value for our, our sample. Okay, we just compute the test statistic. So that is the one place that is a little bit different. And then, with the traditional method, we then compute z, and then based on what our z-value is and what we found the critical region to be, or more importantly, the critical z-values that define the boundaries of that critical region, then that's how we'll make our decision. We'll make our decision based on, well, essentially, does the z-value fall into the critical region? And if it does, then that's sometimes also known as the rejection region. If it does, then we'll decide to reject H subscript 0, reject the null hypothesis. All right. On the other hand, with the p-value method, we've already computed z, and so we're going to go ahead and find, I should have used the word the, but we're going to find the p-value that's associated with that z-value. All right, and then we're going to make our decision based on what that p-value is. If that p-value is less than or equal to alpha, then we reject H subscript 0. We reject the null hypothesis. If it is greater than whatever alpha is equal to, then we fail to reject the null hypothesis. Remember, we don't accept it. We just say, okay, well, I guess so. All right, that's slightly different than saying yes. Okay, so we find the p-value, and if it is less than alpha or equal to alpha, doesn't really happen, then we reject the null hypothesis. So the next step in either case is to make the decision. So I'll just say decide, and it's the same. So decide. There we go. And then finally, after we've made the decision to either reject or not reject the null hypothesis, then we summarize. And apparently there's two M's in summarize, I've been told. All right, that's a long word, so we'll say that is the same. Okay, so it's maybe not that I'm a perfectionist or anything, but I would like these to, correspond to one another. I'm not going to redo all of the numbers, but let's redo the arrows at least. Okay, so that is our little side-by-side comparison of the traditional method with the p-value method. So let's move on now and look at what these mean in terms of a visual description. So we'll move to that in the next page. Okay, so I'm going to just quickly go through example 8-6 on the cost of college tuition. Let's read the question really quickly. A researcher wishes to test the claim that the average cost of tuition and fees at a four-year public college is greater than $5,700, $5,700. She selects a random sample of 36 four-year public colleges and finds the mean to be $5,950. The population standard deviation is assumed to be $659. So here the question is there evidence to support the claim at alpha equals 0.05? Use the p-value method. So in this, I'm going to quickly compare and contrast the p-value method and our old familiar, well, at least old or slightly less new, traditional method. So the first step, well, step 0 is over here. I've written down mu is 5,700. It's going to be a right-tailed test because why? Because the researcher wishes to test the claim that the tuition is greater than 5,700. So we are not only just saying that it's different, we're saying that it's more. So that's why it's going to be a right-tailed test. We've got the value of alpha as the standard one, 0.05. Chi-bar they already gave to us is computed 5,950, n is 36, and sigma here is 659. So that's all of our information that we have. Now the first step is to write down the hypotheses. So H subscript 0 is mu equals 5,700. So remember, H subscript 0 is always a statement of equality. H1 is mu is greater than 5,700. So here, notice the value that we're comparing our population parameter to is the same. Don't be tempted to come over here and use this sample information. Remember, we're making a claim about the population parameter. Okay? We have the sample information from which to work, but we're only talking about the parameter mu in this particular case in our hypotheses. Step 2 is to find the critical region. So here we're basically looking for the area underneath the curve extending out in the positive x direction. The area underneath the right side of the curve, right? Because it is a right-tailed test. And the area underneath this section of the curve is going to be exactly 0.05. And so here we'll apply standard methodology using table E, that's our standard normal distribution table. We find this critical Z value, 1.65. And so we're predefining what the critical region is, and then we're going to go to step 3, which is to compute the test value. So we do this computation, we plug in 5,950 in place of chi-bar. We have 5,700 as the projected or hypothesized value for the average that we're comparing this parameter to. We're saying it's more than, and we make up this amount. So that's what we're doing there. Okay. And then we're dividing by sigma, so that's 659, and then notice that this division here, 659 divided by the square root of 36, that has to be done first, and then that is the whole denominator that we're dividing the top part by. Okay, so we turn to the calculator and that whole calculation. Okay, so calculator says 2.28. And then, in order to make the decision, here's what we do. We say, okay, well, let's see, where is 2.28? This is a Z value, okay? So where is it on our Z axis? It is right here. There's 0, there's 1.65, there's 2.28. So it is in this range of Z values that we've already predefined, this range here going on out. And that was where our test statistic landed, so to speak. So that's why we make the decision to reject H subscript 0. And then finally, we'll summarize the results. So we summarize the result as follows. We say the evidence supports the claim that the average cost of attending a four-year public college is greater than $5,700. Okay, so I want to just run right back through the same example 8-6, on the cost of college tuition using none other than the p-value method. So here, step 1 is, as we remember, absolutely the same. Mu is going to be equal to 5700. That's our null hypothesis, H subscript 0. H1, the alternate hypothesis is mu is greater than 5,700. So here we're going to be using a right-tailed test. Greater than right. All right, if we compute the same exact test value, so it's still 5,950 minus 5,700 exact, all divided by 569. No, sorry, 659 divided by the square root of 36. And so that, what it used to be on the last page was 2.28. Okay. So now let's go to the p-value. P-value is, well, what is the connection between the traditional method and the p-value method? Here it is. So here is our Z value, 2.28. That's our test statistic. And the p-value, we'll look it up, but it is essentially the area underneath the curve going in the opposite direction away from the mean. Right? So this is in the direction away from whatever the null hypothesis is saying. Okay, so how do we find this area, the section underneath the graph that I've shaded in orange? Well, this is a right area, so we'll have to look up the corresponding left area over here, this side, and then take that value, whatever it is, and subtract it away from 1. Or, you know me, I'm going to do my sneaky trick of just plugging in negative 2.28 into our z table, our normal table. So negative 2.2, and then we'll slide over the 8 column, 08 column. That gives us 0.0113. So that is that area right there, 0.0113. So that right there is exactly our p-value, 0.0113. And so here we had the same level of significance. Alpha was still equal to 0.05, and notice our p-value is less than alpha. This is less than 0.05. So what is our decision? We arrive at the same decision. Okay, we should. These are equivalent procedures. They're different, but they yield the same result every single time. And how do we summarize that? I forget, so I'm going to sneak a peek back at the previous page. There, I should have just stuck my neck out and written that anyway, because that is a usual, standard sort of generic answer whenever we reject H subscript 0. We say the evidence supports the claim, because remember, usually the claim is whatever is stated in H subscript 1. So if we throw away H subscript 0, then that means we've found sufficient evidence to back up whatever the whatever the alternative hypothesis is. All right. So what is the connection between between the p-value method and the traditional method? Well, basically, the best way to visualize what's going on here is to compare the distribution curve and what's going on underneath that. So here, I'll just go to another page and focus in really carefully on that portion. All right, so here we have the distribution curve. We had the z value that we calculated was 2.28. Just got to look back real quick. The borderline for the critical region was 1.65, so that was our critical z value. And here, when we're using the traditional method, we were saying, okay, this shaded in area, right? This is equal to alpha, so that has an area underneath the curve of 0.05. And we were basically setting up this region and then not looking at the area that was underneath the curve to the right side of 2.28. We were just looking at that z value itself and saying, oh, okay, that fell to the right side of this boundary value, this critical value, 1.65. Okay? And in the case of the p-value method, there we calculated our test statistic, 2.28 for the z value. We did that first. And then we said, okay, let's look up the p-value in the table. That gives us the area underneath the curve. That we found was 0.0113, to just peek back at my notes. And we said, okay, well look, this p-value, p, is less than alpha. There's alpha. So that means we reject the null hypothesis. And on the other hand, or kind of by the same token, we said, okay, this z value here is in the rejection region. It's over here. So we'll reject the null hypothesis. And the analogy that I want to just throw out there kind of makes sense to me because, you know, I thought of it. So we'll see if it makes sense to you. The green region here is the traditional method. And I kind of visualize this as, all right, we got to park the car. And we're going to park the car in the garage. So when we're using the traditional method, we say, okay, here is where the garage is. It is this green zone, right? So as long as you pull your car beyond that green zone, you don't have the tail end of the car sticking out here, as long as it's in here somewhere, then you have done it right. Park the car in the garage. It is in the critical region, so we do whatever that means. We reject the null hypothesis. All right, to look at it from the viewpoint of the p-value method, in this case, we don't look at that. We don't look at where the garage is. I'll carefully try to release all of this stuff and then. Okay, so we don't look at where the garage is. We just say, okay, well, I can figure out whether I can park the car or not. Let's see. Can we do it? How big's the car? So I measure. I said, okay, let's take the z measurement, and then what is the p-value? The p-value, here I'll shade it in red this time. The p-value is how large of a portion of the area it takes up underneath this right tail. So essentially, that's kind of like a measurement of how big is the car. And we say, okay, if the car is smaller than the garage, so here we have the p-value 0.0113, that's representative in this metaphor, this analogy, as the size of the car. And here is our alpha value, that's the size of the garage. We say, okay, well, I don't care where it's scooted to inside the garage. I just care that it fit. And in the other respect, we say, I have no way of knowing how big the car is. All I care to see is whether it cleared this line right here. As long as it's not sticking out to this end of that line, then it's in the garage. So it's basically two different perspectives of looking at the same problem. We're both, in both of these instances, we want to know, did we park the car in the garage or not? And it's kind of like we've got these two different ways of approaching that question. On the one hand, we look at where the tail of the car is. If it's hanging out of the garage, no, we can't fit it. If it's inside the garage, yes, we can. So that that's the tail hanging out. It's inside the garage. Whereas the other frame of reference, the other way of viewing it, we basically measure the volume of the car. That's this p-value, this shaded in area over here that I keep going over with red and then orange. Anyhow, we say, okay, as long as the car is small enough, then it will fit inside the garage. If the car is too big and it fills up all of the garage and it fills up and it spills out beyond there, well then if my p-value is larger than whatever alpha is, then I know that car is not going to fit in the garage because I know the car is bigger than what the garage is stated as. So let's end there. That's our wrap-up of comparing the p-value method and the traditional method of hypothesis testing. And here, of course, we were testing using the z-test for mu. All right.